Great. Welcome everyone, and we'll just wait a few minutes for everyone to come in and pass through the waiting room, and then we'll get started. We'll just give it a minute more, Francis, and then be ready to go.
Yep.
Great. Looks like it's stabilizing. So thank you to everyone who's joined us for this evening's public lecture, our April public lecture. And we're delighted to have Francis Wall here as our speaker. So many of you are obviously joining us on a laptop, a tablet, or a smartphone. And each of these devices is likely to be made up of over a dozen minerals, which are vital to creating the circuitry and the batteries that keep them all running. And the demand for these minerals is growing pretty much day by day as we develop even more technologies, green infrastructure, green technology. So this evening, Francis will be exploring how we can ensure that as we ramp up the demand for these minerals, we're getting them in a responsible and sustainable way. So Francis is a professor of applied mineralogy at Camborne School of Mines at the University of Exeter, where she researches the geology, processing, and responsible sourcing of minerals, and especially minerals for technology and critical raw materials. So just before we get started, we will have a few moments for questions at the end. So if you think of anything as it comes up, please put it in the Q&A box, and we'll do our best to get to all of those questions before we leave for the evening. And with that, thank you, Francis, for joining us.
Thank you very much, and good evening, and thank you for the invitation to give this talk, which is about one of my favourite subjects, and I hope it's going to be of interest to people here. And I normally find that it's a nice, easy subject to talk to people because we are all consumers, we all rely on manufactured goods, and so we can all have an opinion about these things. So this is a talk then which deals with solar panels and smartphones and wind turbines and electric cars, and really the green tech and high tech goods that we use every day and take for granted and need to decarbonize and go through the energy transition to fight climate change. So these are things that are the headlines of manufacturing. Well, this is the Geological Society, and I'm a geologist and geochemist. So what am I really talking about this evening? And if you read the blurb, you'll see it's really about minerals, of course. So I'm going to be talking about responsible mining, and responsible mining of minerals is really just simply about maximizing the positive aspects of mining and minimizing those negative ones. And we often talk about responsible sourcing and responsible sourcing schemes, and they really give the assurance that the responsible mining is being done. And so in this 45 minutes or so to come, 50 minutes, I'm going to talk about responsible mining and sourcing and introduce the concepts of critical raw materials and conflict minerals, and talk about these things that are all absolutely at the beginning of manufacturing. And so why did I give this talk the title Responsible Manufacturing? It's really because I think that often as consumers, we really do take these things for granted. And in places like the UK, where we don't have much of a mining industry anymore, we kind of forget about the fact that everything that we use is started off its life, the materials in it at some stage in the ground and had to be extracted. And I think now that we want to manufacture electric cars, especially in wind turbines, suddenly we've realized again that we actually need this stuff and we need to be able to secure supplies. So it's suddenly come much higher up the political agenda, I think, in the UK. So I'll be talking, because it's a geology lecture, then I'll be talking about some issues of mining, but actually really talking to you a little bit about some of the research we're doing now to connect geology and what we do in exploration geology to responsible sourcing, and like keywords like process mineralogy, and I'll even do a little bit of life cycle assessment. And hopefully there's something in here for everybody, some things that aren't very technical, a couple of slides that are a bit more technical if that interests you. And of course, we're all consumers, so everybody can have an opinion about this and have a chat at the end. So Becky made the first slide and she put a banana on it, very nice banana. So in celebration of that, I went off and I took a photograph of my bananas this morning to put onto this slide for you and start us off thinking about responsible sourcing. And I guess when we go to the supermarket, then we might very often buy fair trade bananas like this, or fair trade tea and fair trade coffee. And that's probably do that with hardly thinking about it if we're used to doing it now, because it's very much a fact of life. Many cafes only serve fair trade coffee, and we know that, Mark. And in doing that, we are saying that we want to give farmers the source a fair trade price for those goods. And when we go around the supermarket, we'll see lots of other marks on goods, like some of the logos I've put onto this slide, and you'll choose whether or not you want to pay that little bit extra that it may be in order to have the product with that mark on it. And in that way, as a consumer, you're choosing to buy responsibly sourced products. I guess I could just leave you a minute to have a look at those logos and see what you recognize and what you would choose to buy. And if I went to my cupboards and I looked at the packets, I noticed more and more different logos certifying more and more different things. And so as consumers, we're given this whole choice of how we want to consume and what we would like to buy. But what about minerals then? We don't go into the supermarket to buy minerals, but there are actually mineral schemes straight away that I can tell you about, and they work best when they're things like bananas. So you might remember in the end that this is a lecture about mining and bananas or something, right? So minerals work best in responsible sourcing scheme when they're like bananas and when you're buying something that you can easily recognize. So if you're lucky enough to be going and buying a large and reasonably expensive diamond, it will be certified through the Kimberley process, which is there to stop smuggled and blood diamonds that were financing wars getting into the supply chain. So that's a responsibly sourced diamond. There is a Fairmined scheme, which came out of the same scheme as the actual fair trade ones that I showed on that logo, and that's now for gold. So if you want to, when you're buying jewellery, you can seek out, just do Fairmined, I think it's fairmined.org, just on a search engine, and you can go and buy fair trade, Fairmined gold to go into your jewellery. And if you go onto the high street, into some of just the normal high street jewelers, you can go into the shop, and if they haven't got a notice in the window, you can go and ask if they belong to the Responsible Jewellery Council, and that's a scheme that has a set of rules, and if miners want to sell into the jeweler manufacturers in that scheme, then they have to meet a certain set of rules for how their mining is behaving. I went into one in my local town in Truro, and I went and said, "Are you a member of the Responsible Jewellery Council?" And the lady smiled very broadly and she said, "Yes, we are." And then she said, "And you're the first person that's ever asked me if we're a member. So please do go and ask, because the jewellers are already up to speed with responsible sourcing of minerals and taking part in schemes. How well they work, that's another discussion and another day. But of course, they're there, so please do go and try them and use them. But what about this? When we go out to buy a car, how can you manage that? Cars are not like bananas. They're made of thousands of components. Have you ever heard of a fair trade or Fairmined car? And of course, this is a much more complicated thing to deal with. And so what I'm going to do is to lead towards maybe soon. I think that there may be marks on cars like this to say actually that the manufacturers have taken care where their things are coming from. And this is a rising agenda globally and particularly in Europe. And so why then? I'm going to explain the background a little bit, and then I'm going to talk a bit about responsible mining, and then go off into some geology and how we can compare deposits and make mines as good as possible. So an electric car then, this is similar to normal cars, if you like, because they've got steel and plastic and aluminium and rubber in the tires. But electric cars have come to the top of this manufacturing agenda and the sourcing agenda because they have different materials in them. So every car will have copper, but an electric car has 4 times more copper than an ordinary petrol or diesel car. So the demand for copper for cars will go up. And then an electric car will have a suite of more exotic elements, lithium and cobalt and graphite and manganese and nickel in the battery, and things in many of these cars like neodymium and praseodymium and dysprosium, which are part of the rare earth family of elements in the permanent magnet motor that drives the car. And these are really new elements into manufacturing because an electric car will have tens of kilograms in these elements. And many of the previous applications of these elements only needed a few grams. There are probably 50 magnets in an ordinary car made of rare earths, but they're very, very small magnets. And suddenly these things need tens of kilograms. So what we need is changing, and that's really highlighted to everybody from Tesla through to VW and Audi, and all of the manufacturers are having to look back through their supply chains and think about where the stuff is going to come from that they will use to manufacture their cars. And so that leads to this statement from the World Bank that altogether, they reckon 550 million tons of copper have been in the last 5,000 years, and in the next 25 years, we will have to mine about the same again. So the amount we need to mine is going up rapidly. And that's because of the rising number of people on the planet as we go towards 2050 and up to 10 billion people. It's because of a good news story, sometimes called the rise of the middle classes, that people overall globally are getting wealthier and can buy more things. And that is all now exacerbated by the energy transition, because electrification is material intensive. So we move out of the age of fossil fuels, we're moving into the age of metals. And all of those things conspire together to produce that headline for copper. And they also conspire together to produce this headline. It's not just about needing more materials, it's needing that wider range of materials than ever before. So this is a pretty graph that many people use, and it goes back to 1700. And if you look, it's about energy pathways, how we generate energy. And when it was just windmills and water wheels, the number of materials that you need for that is very simple. And nowadays, when it's about solar panels and wind turbines and cars and the electrification generally, we're talking about over half or 2/3 of the periodic table even in these devices. So as geologists, then we're challenged that we need to understand and learn about many more types of mineral deposits, which is lovely if you like doing geological research, but they have to come from somewhere. And often they're not mined in very large quantities, as I think, I'm going to come to that in a minute. Let me just hold that thought for a second. Let me come to it in a minute. I just put a little diversion in here to say if elements like dysprosium and neodymium and tantalum and strange things like this you haven't really heard of much before, if you go to sosrare.org and click on outreach, we've produced a Happy Families game, and you can have some fun and have a look at what some of these strange elements are used for, like smartphones and lighting and so on. Okay, let me just come back to my story then. Okay, so let me just come back here a minute and say, so some of these elements like lithium at the moment and rare earths, they're called critical raw materials. And I'm just going to come back to that in a minute to describe to you what a critical raw material is. Because although we're using more and we're using a wider range of elements, we're not going to, in the earth, run out of anything as far as we can see. So sometimes people look at what the United States Geological Survey or the British Geological Survey have in their records of what's been mined and what resources and reserves we know about, and that they divide that up by the number of years and work out we're about to run out of copper or run out of neodymium. And that's not true. There's plenty in the earth of all of these things. As we use things, geologists go out and they explore and they find more deposits, and that's what this graph is here. The copper production is going up, but so are the reserves, the deposits that we know about that are ready to mine, and they're holding more or less the same ratio. But the problem is that, can you make supply and demand match up? So there's reasonably priced material when you need it. Can you mine it cheaply enough? And really importantly now, can you mine it at the cost that we are prepared to pay to the planet? Because as we go to lower grade ores and these huge mines, the amount of energy that we're needing for crushing and grinding rocks and then even worse for processing these into the materials that manufacturing uses is going up. And as planet resources are squeezed and we actually want to decarbonize the mining industry, just like we want to decarbonize all the other industries, how are we going to do that? So metal availability itself isn't the really big issue in mining at the moment, but providing metals with the minimum environmental impact and the maximum positive social impact is the big challenge that geologists and mining engineers and mineral processors and environmental scientists are all facing at the moment. And for some of these things, like iron to make cars or copper to make cars, you'll see that they're mined in huge amounts every year, millions or billions of tons. But some of the other things, like neodymium and the other rare earths and lithium in batteries, they're mined only in hundreds of thousands or tens of thousands of tons. And even though the amount of lithium we need to mine each year will probably have to go up by 5 times, even with recycling and so on, to mitigate the impact of needing more materials. It's going to go shooting up. We're still not going to mine anything near the amounts that we do for copper and iron. And that means that you don't need all that many mines in the world to provide the supply. And so that means that these things like lithium and rare earths, they have the technical name critical raw materials, and that is a specific definition, and it means they're economically really important, as in they make the batteries in electric cars and all kinds of things that rare earths do in addition to those direct drive motors, so we can't manage without them. But the supply is vulnerable to disruption, and that supply is normally vulnerable because the mines are concentrated at the moment in just a few or even one country. And that's what the slide is in front of you now. This is the European Union critical raw materials list for 2020. And you can see they've got lots of materials there. You can see all the element names on there. And if you look across, there's DRC. Can you see the big green country in the middle of Africa? Cobalt, 59% of the world's cobalt, which is important in car batteries, is coming out of DRC. And if you go across to the right, then can you see that long list on the slide? These are all the critical raw materials for the European area that are dominated by just one country. And of course, that country is China. And while we in the West have been concentrating on service industries and maybe very specialist manufacturing, importing components and processed materials, China's not been afraid to really get going with their raw materials and stay mining and import and process raw materials. And they now, and this is on purpose, they really dominate the supply of many of these critical specialist raw materials. And so this is an interesting political situation, as well as an interesting economic one, and quite high up the political agendas at the moment. And obviously, this is nice for geologists because although this map, of course, is based on geology, you have to have the deposits before you can mine them. For any one of these commodities, if I showed you the distribution in the world, it would be a much wider distribution than the current mines themselves. So there's plenty of scope to diversify supply if we can make it work. And European Union, of course, wants to do that. And how can you beat China because they've been so clever? Is there any way to do that? And I think Europe, one of the things it's really looking to is this responsible sourcing agenda, is to say it's not just about buying it as cheaply as you can. We need manufacturers to be looking for responsibly sourced raw materials, and that could give other suppliers, other miners, the chance to come into the market if they're better, more responsible suppliers. And of course, this is important because it really changes the geopolitics of energy. It's a slide here from a paper by Damien Jerko. And if you look at the oil producing countries, they're in the northern hemisphere in grey on the left. And if you go to the lithium producing countries at the moment, they're generally in the southern hemisphere. And you can see China, but also South American countries and Zimbabwe, that is in Africa, and Australia. And so as we move away from fossil fuels into the age of metals, some of the global power is likely to change hands, making very interesting political situation. And besides the geopolitics, then every now and again there comes some headline like this. If we're buying electric cars, it's because we want to feel good and be doing the right thing and having a low carbon car. And so we don't want to see headlines like this from Amnesty International's website. Is your car, or in this case, is your phone powered by child labour? And this is a headline all about the element cobalt, which is in car batteries and in phones and in many other high-tech goods. And what they found is that as the price of cobalt's gone up, lots of informal mining's come into the Democratic Republic of Congo. And so some of those informal mines, they were using child labor in pretty much slave labor conditions, really horrible conditions. And there was no way of knowing whether the phone that you've got in the hand or the electric car that you're buying has got cobalt, which is from a well-run, well-operated mine in the DRC or elsewhere, or whether your cobalt comes from one of these sources. And this is really why we need responsible sourcing schemes, so that as consumers, when we buy things, we can be sure that that headline doesn't apply to us. So then now, after the first part, then setting the scene, let's have a think about mining. So mining, where all these raw materials, where our rocks are taken out of the ground. What is it? Well, much of it today is international. It's really super large scale with huge trucks, huge hole in the ground, or underground mines, becoming digitized and automated very quickly. And the companies really take a lot of care about what we call social license, which is about being good neighbors around the mine and to the country they're in, and making sure that they can try and get public acceptance of what they're doing and that they have good governance of the mine. So that's one view. But of course, don't forget that many mines are still small scale. And although most of what is mined in the world comes from large scale industrial mines, it's reckoned that as many as 100 million people in the world, families, depend on these very small artisanal and small scale mines for their income. So there's a whole nother world where most of the miners in the world are small scale miners, which is an interesting talk for another day. But you can see how this then will bring about different responsible sourcing schemes. So Fairmined, for your gold in your jewellery, we'll look at small scale gold miners probably, whereas other schemes need to deal with the large scale mines. And so done well then, mining can, and I call this my green slide, it can produce the metals and minerals we need, it provides well-paid jobs for local people, it's really an international workforce as well as local people take care to make sure there's best practice in mining, and you get a lot of expertise moving between countries. Can benefit national and local economies, certainly, enhance the local community, improve their quality of life, act as a catalyst for other industries in the area, and really drive sustainable development very much, and the Sustainable Development Goals. But equally, done badly, if your mine is not going well, it can create environmental pollution, it can actually drain money out of the country, use up valuable resources like water and energy in the country, displace local people who were living there, it can kill people if your health and safety record's no good or you've got terrible pollution. it can finance wars, a bit more about that in the next slides, and create poverty. So it actually does the opposite of what you'd be wanting mining to do. And sometimes this is given the name resource curse, because that is indeed what's happened in some countries. So for responsible mining, then, we want the upside of mining. We want to be able to be assured as consumers that the mines providing the raw materials for our goods are these ones. And here's my own list of what a responsible mine needs to do. So a mine must make money. If it doesn't, you're in problems straight away, not only because it's a business, of course, so it has to survive as a business, but when mines go bust, that's often when you have the biggest pollution and other problems with them. So certainly we go for that. Obviously, it's got to abide by the laws and preferably do better than that and follow best practice. It mustn't pollute, must be resource efficient. That means not creating loads of waste. If it can help it, it's got to be energy efficient as well as material efficient. Must look after the site environmentally and put it back in a good state. That means remediate it. Obviously got to look after its workforce and local communities, and it's really got to communicate well and have good governance with the communities and the country it sits in. So overall, then you might make a slightly different list, and if you look at schemes, they'll all have slightly different ones, but the point I'd like to make is a responsible mine overall has a lot of things on its checklist that it has to do. And what you often see in the headlines is people picking individual humanitarian often aspects will steal the headlines, like is there child labour in your mobile phone? But overall, when you have a really true comprehensive responsible mining and sourcing scheme, it needs to look at this wide range of issues. And so what does that mean then for geologists? So let's come back to think about that. So what do geologists do? Well, geologists know about rocks, and they're the first people that go out explore. So when we're thinking about opening new mines, maybe we need more lithium or more rare earths, then it's geological exploration companies that go out and they go through this value chain. So the geologists go out and find the ore, then they'll work with their colleagues, mining engineers, to design the mine, and then they'll have to design the process by which the ore is taken out of the rock, and then the process by which the elements that you want, like lithium, is taken out of the mineral, out of the ore mineral. So that's the main chain that is used on a mine. And these days, to get a responsible mine, all of that has to be done in this cocoon, if you like, in this environment and social responsibility area. And right from the very first stages in which we as geologists think about what new bits could we look at, then we need to be thinking about how will they perform environmentally when they're mined and processed and extracted. And we need to always be looking forward. So it's not just about which are the best, the biggest deposits or the richest deposits. We have to think much wider than that now. And I just put Sustainable Development Goals logo on here just to remind me to say that mining, of course, is a very complicated topic if you think about how it interfaces with the Sustainable Development Goals. So there are many things about providing jobs and alleviating poverty, looking after the environment that would be positive towards many of the goals. And if you're doing the opposite and creating havoc and environmental pollution and so on, then of course that would be negative against many of the goals as well. So it's a bit of a balancing act in mining. It can be a very important activity in an area, as I say, pushing a country towards positive sustainable development, or in a bad scenario, driving it the other way. So it's really important to get these things right. Okay, so no pressure, geologists, then, because that's what we are the first people who look at that. And there are many countries that are really looking at the energy transition and the requirements for more metals, and that is exactly how they want to help their sustainable development. And the World Bank have seen this issue and have an initiative called Climate Smart Mining, where they talk about, if you go to the website, just put in climate smart mining and have a look at it, talk about what needs to be done to make sure that responsible mining, responsible sourcing of our metals is driving forward the right kind of sustainable development. So let's come back to responsible sourcing again then, and having looked at mining and sustainable development, I'd now like to tell you a little story about one of the real first things that in the late 1990s and 2000s hit the headlines and is really, I think, at the root of the responsible sourcing agenda that we see today. And that's the issue of conflict minerals, which are the ores of the elements tantalum, tin and tungsten, and also often gold is put with that. And so we have a piece of jargon, 3TG, that we can trot out with respect to responsible sourcing. And in the hand there, this is a picture taken in Rwanda, and this has some Colombo tantalite there, some cassiterite, which is the ore of tin, and that's 2 of the 3T. And you can see that these things are mined and they're often really moved around in those kind of bags. So they're not quite as good for smuggling as diamonds that you can put in your pocket, but these kind of commodities that you can move around, really, these can be shipped and smuggled and used to finance things like conflict and wars in the same way that you might have heard of blood diamonds. Okay. And so this mineral then, coltan, jumped into the headlines, just like cobalt jumped into the headlines recently. Coltan jumped into the headlines, say in the late 90s and then through the 2000s. And a bit of geology and mineralogy then, you say, what is coltan? And it's what the journalists used as the short name for the mineral columbite tantalite, which you see there is an iron manganese tantalum niobium oxide, and it's the ore of tantalum. That's what it is. It's where tantalum comes from. And why do you need tantalum then? You might be thinking, and why did we need suddenly needed more tantalum than before? And the answer is, again, mobile phones, because tantalum makes very good small capacitors. And when people wanted to go from the brick size mobile phones down to the nice small ones that we have at the moment, then they needed more tantalum to make more of these nice small capacitors. And suddenly more sources come online. They come online from informal mining. And unfortunately, that coincided with conflict in first of all in Rwanda and spilling over into the eastern side of DRC, which was in a state of confusion. And the warlords there found that they didn't have diamonds to ship around, but they could ship this coltan and associated minerals and smuggle it from DRC across the border into Rwanda and out from there and finance their wars doing this. And who wants to have a mobile phone that's financed somebody's wars? Again, the journalists got this into the headlines, and then this became a problem that was looked at in government circles. And so this is what the countryside looks like. It's a very beautiful area there in the eastern side of DRC and in Rwanda. This is pictures when I went to Rwanda in 2014. And there are lots of small scale miners there, really important industry in Rwanda. That's all completely legitimate. But how do you know whether your coltan is legitimate or legitimate from the DRC over the border, or illegitimate finance coming from illegal mines financing wars over the border in DRC? So again, it needs some kind of responsible sourcing. And I've highlighted because this is the issue, and I think it's pretty much the only responsible sourcing of minerals issue that's got right through into legislation. And after making the headlines, it got in 2010 in the USA, they passed the Dodd-Frank Banking Act to say that if you're using tantalum or tin or tungsten, and you need to be aware, you need to be sure, you need to have assurance, a responsible sourcing scheme to say that your tantalum or tin or tungsten is not financing the war in the eastern DRC. And the European Union is a bit more bureaucratic and slower, but finally it passed legislation too in Europe, and it came into force. It instantly past midnight on 2021 this year. So the UK did not enact the responsible sourcing law, unfortunately, but everywhere else in Europe, if you are dealing with tantalum, tin, tungsten or gold, you have to know that it is not coming from a conflict afflicted area anywhere in the world. So this is a responsible sourcing scheme, really high profile then. It's pretty much a one issue scheme because it's only about conflict. It doesn't tell you anything about the environmental performance of the company or the other social performance of the company. But this one issue was so important that it's actually got responsible sourcing right to the top of the political agenda. And what is the scheme then? Well, it's we tried all kinds of mineralogical things. We tried in Germany, very clever, to actually trace the individual mineral grains themselves, and none of that was cheap enough and fast enough. So these are locked bins that you can see in the center there. And the stuff comes from either a mine like you see a rock drill on the right, or from those small scale miners. It goes into the bins, it's locked away, and then there's an accompanying paper trail that goes with it as the insurance. And it's run by one of the industry organizations in London, runs these schemes. Of course, it's ripe for maybe some kind of blockchain scheme or something now, and that's there's various research going on that now to see how that could be improved. And so when you buy your mobile phone now, I think that really the world has changed, and you're much more likely to be assured that it's a responsibly sourced tantalum. So from that story then, let's just think about who controls responsible sourcing. And on this slide then, I would say that in mining, right from maybe the early 2000s, they suddenly realized that people didn't like mining companies very much, that they had a bad reputation for all the things on my red mining slide, for not being good neighbors, for not helping countries with sustainable development, for taking the money out, for the miners getting rich and the countries and the local people not seeing those benefits. And so I think the mining industry overall has been working really hard on that, on being good neighbours. And that's what's on the left there, is the social license to operate from the surrounding public, about abiding by the law and doing all the right permitting and behaving well to their shareholders and the bankers. And I would say that although maybe we often like to make bankers not the hero, shall I say, of any story, they are certainly a hero of responsible sourcing of minerals. And a really good current example, of course, is the Church of England, who are a big investment organisation, and they have really led some of the big initiative to sort out tailings dams safety. So they said, we don't want to be part of this. We don't want our money invested where it's going to cause those problems, but this is an important industry, so let's do something about it. And there are schemes that the banks have routinely now when they lend large amounts of money, that miners and exploration companies have to comply with certain environment and social standards before they'll get their money. So that's really important, and that's controlling responsible sourcing. But the other really important thing is the manufacturing chain, and I think that comes here from consumer activists who read about high profile issues like that child labour and cobalt story. They say, eek, we don't want that kind of cobalt in our cars or in our phones. And so, okay, imagine that that's you or me. Well, I'm very bad at work at Camborne School of Mines. I do know some mining companies, but let's assume it's you, and you're not au fait with the mining industry. You don't meet people from the mining industry. That's really hard to go right from being the consumer activist on one side of that slide there to go and knock on the doors of the mines and ask what on earth they're up to. And anyway, when you go to buy your car, how can you, it's not a banana, how on earth do you know where all these things have come from? Take you years to sort out all the components in a car. But you can go to Tesla or VW, or you can go to Apple or Google or any of the really high profile manufacturers, and you can knock on their door and ask them what they're doing. Or you can go to the government, like people did with the Dodd-Frank Banking Act or the European Union Responsible Sourcing, and knock on their door and ask what they're doing. And I would say it's the first of those at the moment, this high profile manufacturers, where people like Apple and Google have turned around and they go back into their manufacturing supply chain. So they'll find they don't know the miners either, but they can ask the next person back and the next person back. And sometimes they will reach straight right back to the mines, like Tesla did recently. They needed to assure nickel supply and then just went and bought a nickel mine. And that's something, that kind of vertical integration we'll see happen maybe more as people go back and need to assure their raw materials for some of these things. So it's that influence back through manufacturing, and that's why that's in the title of this lecture again, is really important. And that can be a very long chain, but I think we'll see that coming more and more. And so there's interplay now is to the pull and the push. Will the miners who want to look like good neighbours and they've already got responsible sourcing schemes running, will they kind of filter up the supply chain? Or will it be a pull from the manufacturers saying, this is our scheme, you've got to comply with our scheme, this is the logo we're going to put on our cars and our phones and things. And so what's happening at the moment is everybody's got schemes, okay? Every time I give this talk, I could put another 3 or 4 logos on this slide, okay? There's a whole forest of schemes, but as consumers, we probably don't see these every day at all. So probably these logos might all be new to you, but they're there and they're being used by manufacturers and other government organizations looking at what the miners are doing. And let me just translate a couple of those. So when I said the bankers are heroes and the investors are heroes, then the bankers one is the equator principles that they say that exploration companies have to comply with before they'll lend them money to build their mine. ITSCI is the tantalum one, the conflict minerals scheme. The International Council on Mining and Metals is based in London, and that leads all the big mining companies have come together to try and set international standards for people. And let me pick out Initiative for Responsible Mining Assurance, that certifies the actual mine site itself. And I'll do one more, the Aluminium Stewardship Initiative, because that's a really interesting one. That goes along the value chain, right from the mine right up to Marks and Spencer's shops at the other end. And so you can see different logos doing different things, just like when you go to the shops, and that's coming into the minerals and mining industry. So having done that, then now let me take a very quick excursion through some of the research that we are up to at the moment to go alongside these responsible sourcing initiatives. So I'm going to take our rare earths, the neodymium in the direct drive motors, which is this group of elements from the periodic table here. Don't worry if you're not interested in chemistry, there's not much chemistry coming, but I'll show you some minerals. So rare earths, then a group of 17 different elements in the periodic table, of which this one here is the #1 rare earth at the moment. It makes these really strong permanent magnets that make direct drive motors in wind turbines and electric cars, and loads of other applications for rare earths too. They all come from China. So China has about over 60% of rare earth supply in the world at the moment. It's far and away the leading supplier and manufacturer with rare earth elements. That's on purpose. Very good strategy that's worked very well for it. But it has one Achilles heel, if you like. One problem is that in its mines and factories, it really has a legacy of poor environmental performance. And this is an article from some years ago now, but I like the HTML link. If you have a read of it there, it's from the Daily Mail and it's still live. I tested it before this talk this evening, so you can go and read the article. And it has their 2 villages, Suberen and Yanmanjiahong, at Bioto in China, where the world's largest rare earth mine is situated, and everything behind them is completely barren. And that's the tailings lake that the mine and processing has produced there, and as the Daily Mail tells us, has devastated their farmland and ruined the health of the people in their community. And you're sitting in front of a computer, it's got a disk drive in it, it's got pretty colors on the screen. You will have rare earths in your computer, in your low energy lighting, never mind if you've just bought an electric car. And if it's neodymium, it may well, it's a very good chance, more certainly better than even. It's probably about 80% chance it indeed even came from this mine. And so you're contributing to those people's hardship. And this then is maybe China's one Achilles heel. It's trying to sort out its environmental performance, but it has a long legacy of poor performance. And so that means that new companies, if they can persuade us as consumers that we want responsibly sourced rare earths, that's an opportunity for them. It's an opportunity because all the rare earth deposits aren't in China. I'm not going to go through this map in detail, but just have a look. There's lots of coloured spots all over the world, lots of rare earth deposits, lots of companies now out and about exploring for rare earths, buoyed up by big headlines that we're all going to have offshore wind turbines and we're all going to drive our electric cars. And so there's investment in looking for the best rare earth deposits. But which are the best rare earth deposits? Okay, that's a good question. And this is where it comes to what I was explaining just now, that as geologists, we can think about this right in the first stages of exploration and also in our research, making geological models for deposits. Because if you look at this slide, lots of the basic stuff about how rich is the ore, what's the composition of the minerals in any ore, including a rare earth ore, which I'm using as this example, what's the depth of it, what does it look like? This all will affect the things that go onto a list of responsible mining characteristics, which I've got on the right. And we link them often through a science called geometallurgy. That means as geologists, we often look at rocks and we think like backwards. What we want to know is, how did that rock get there? How old is it? How was it made? What was life like? What was the earth like when it was made? And for this, for responsible sourcing and responsible mining, we put our process mineralogy hats on, and instead of thinking about the story of the rock, we think about the forward story of where it's going to go to when it's mined and how it's going to be processed and how it will perform and behave when it's processed. Okay, so that's all the things on the right. And some of the things I've highlighted in yellow about how much energy will it use, what will the carbon footprint be, what about water, what about environmental contamination? These are the factors, aren't they, of responsible sourcing. So we can be thinking about that right from the very first stages of thinking about which deposits then should we go and explore and what should we mine. And for rare earths, then there are lots of different types of deposits that we might choose. And here are some pictures of some of them on here. There's mineral sands, literally beach sands where the heavy minerals are concentrated. Picture from Western Australia. There's unusual rocks called carbonatites. That's thin section picture in the second one over, and some weathered stuff. You get this weathered soil and some very rich deposits there. Beautiful rocks called alkaline rocks, and this mineral is eudialyte that has rare earths in it. And then the one on the end is an unusual deposit called iron adsorption, which are mined in China, and they're really easy to leach. You don't need to go through all the complicated crushing and grinding stages. So now I've put on some characteristics, which I'm not going to go through in detail, but if you're a geologist, you can read those through quickly. And the point I want to make is all of these different deposits, they have advantages and they have disadvantages. So there isn't the perfect rare earth deposit. Each one has different challenges if you're going to process and mine it. And that's what we need to think of as geologists when we start. So we need to think about, how will this perform? What do I need to do in order to produce an environmentally friendly mining technique and processing technique for this kind of deposit? And maybe for some things there are better deposits than others that we should be thinking about geologically right at the beginning. And so this is a project called High Tech Outcarb from the European Union, where we were making new models, geomodels, for helping exploration geologists. And if you look here, these are just some pictures of the kind of, kind of models that we went from the older 2D models into 3D ones. And then we made these pop-out boxes to think about the mineralogy and how well we can process them. And you can begin to bring in these kind of factors that affect the environmental performance of future mining right into the original information about geological models that will inform future exploration. That's one example. And now let's just take some spin through some exploring for rare earths in Malawi to show how this can work. So here's our colleagues at Makango Resources out drilling to look for rare earth ore at the Songwe Hill complex. Here they are. There's the carbonatite rock. Sorry, it's not really pretty, but it's very interesting. It gets really pretty when you take it into the lab. There's the ore mineral. Look, we would look at how well that's going to process, and the company works out the best and most resource efficient way to process it. And now we can do clever things like applying the technique of life cycle assessment, which I'm not going to go into detail, but this is how you can quantify the environmental performance of an ore deposit. And we've done this not for Songwe Hill on this particular slide, but for another deposit in America at a place called Bear Lodge. And this is quite a complicated slide, but what we've done is looked at how rich the ore is, and the lower on this graph is, so that's the richest ore where my mouse is down the bottom, and the lowest least rich ore at the top. And then this is the environmental footprint of mining in terms of the carbon footprint of mining throughout the whole 45 years of projected mine life. So there's no mine here at Bear Lodge, but when people plan the mines, they publish what they're doing, and we could go and have a look at that and look at the environmental characteristics every year of the mine for the whole 45 years. And so you can bring these kind of environmental techniques of LCA early into the exploration program when you can take important decisions on what your mine will look like and how it will be planned, and put that into the detailed forward modeling of the mine for the whole of its mine life. And that's a really good way to reduce the environmental footprint of future mines. And here's another one which we did with another mining project. And here, if they'd used the coal source that they were offered by the country at first, the carbon footprint of their mine when it's finally built would have been huge. So they said no thank you, and designed a different way of using hydropower combined with some recycling and some coal power at different times. And they were able to really reduce the carbon footprint of the planned mine and any future ore that they will produce. So this is geological territory, if you like. We're the exploration people that run these projects at the beginning, and we now need to step over into these kind of LCA techniques that manufacturers would be more used to using, and make sure that we tie up nicely. Okay, so we're pulling these techniques. It's not on the mine that's working. We're pulling them right back before we've ever built the mine into the geological and planning stages of the study. And if you want to have a go at thinking about all the different things that you have to evaluate when you're thinking about which might be the best rare earth deposits, then we do have a top trump style game about that, and you can look on sosrare.org again and have a look at those. You can download the cards and chop them out and have a game of top trumps gaming on rare earth deposits. Okay, so that's some research that we've done on rare earths then, but now we're starting a new project looking at the same thing for lithium deposits, which are the headlines right at the moment for these batteries in cars and all the other energy storage that we need. And there are some very different sorts of lithium rocks that you could think about how they might behave. And here's a picture of a hard rock deposit, green bushes in Australia. So this is a real tough, beautiful granite pegmatite rock with the lithium ore, the pinky mineral in there on that slide. And that, of course, is going to take a lot of energy to crush and grind it. Whereas the other half of lithium at the moment comes out of these things called salars in South America and a little bit in USA. And these, they take the lithium is already in brines just under the ground. Then they put it in these big evaporating ponds. So they don't do crushing and grinding, so it doesn't need that kind of energy, but it's a huge user of water. And so we're going to develop some life cycle techniques now to compare the different environmental characteristics of lithium deposits and think, what are the challenges in there? How do you balance them up? And are one sort of deposits more environmentally friendly than the others? How do we do that? So that's what we're up to now. And this can come very close to home because we have lithium deposits right here in the UK. Do you recognise this? This is Cornwall. This is the map of southwest England, and the red splodges on here are granites. And I won't go into any more detail than that, except to say that in those granites, in some of them, are micas, biotite black micas that contain enough lithium to be of economic interest. And British Lithium and Cornish Lithium are exploring there. And Cornish Lithium are also exploring in the deep geothermal waters, where some lithium has already been taken out of the micas for us by nature, thank you very much, and put into waters deep underground. And if they can get their pilot plant working, then they can extract the lithium at the same time that the other company at United Downs, GEL, are producing electricity from deep geothermal energy. And so we can look at this, and you can look at this as these projects go forward. They've all got websites, and think about which are the most environmentally friendly ways to produce lithium. If you're doing it this way, this is being done in Germany as well by a company called Vulcan, and they reckon they can pretty much get down to 0 carbon lithium production by taking the lithium out of these geothermal waters. And so we have a responsible sourcing story right here in the UK. You can think about what's it take if these projects are all early stage exploration projects. If they get going, what will it need for them to be responsible mines? And so that brings me to the end of my story this evening then, and I just put up these conclusions to finish with, to go to the geological end of the story and say, well, what do we do as geologists then in responsible sourcing? We can really help establish alternative supply chains of critical raw materials, especially to help diversify and secure supply. We can absolutely help achieve responsible mining and sourcing. And we really need to learn the language of the value chain, and there's another talk on circular economy sometime, to join up to the manufacturers and make sure that the manufacturers are getting this and the supply of the clean tech and digital tech goods that we need, getting it right from the very start. Thank you very much.
Thank you so much for that fascinating talk. So I think we have just a few minutes for questions. I guess one for me is, what is the timescale of maybe bringing on some of these new mineral deposits online and extracting from them? And is it compatible with some of the timelines we're seeing around net zero targets, for instance, ending the sale of petrol and diesel cars?
No, it's scary. It's scary. I mean, some of our friends like Makanga, they've been going, 10 years working on the mines, but they have been going 10 years. Maybe there's a positive story. So you often hear it takes at least 10 years to go from an exploration start to construct a mine and go. But actually the first rare earth bubble was in 2011, and a lot of projects started then. So they're actually coming online now. And the problem is that in this critical raw material space, it can be really hard to get going. And so it's countries that will really strategically support their value chains and get them set up that will kind of win the race. But everyone's in a big panic now. Oh, we want gigafactories. Maybe they don't want mines. Let's not flatter ourselves too much, but they want gigafactories to make batteries. And then they suddenly realize that where's their lithium going to come from? And so we should take advantage of the fact that people are really thinking about geology and the actual sort of these things at the moment, because that time scale is scary, and you can't design something different in a fast time scale either. You can't recycle in a fast time scale because we haven't got enough in circulation. But I mean, that's some of the research we're doing now, is trying to think the whole system through. And byproducts, I would say, byproducts. Go to an existing mine and see if they've got something that they can siphon off the side for you. That's your fastest way to start up.
Thanks. So one quick question is, what was the pink mineral shown that was actually hosting the
spodumene. Lithium mineral called spodumene. Yeah.
That's a great name. And so I'll do one more question, and are you familiar with the Fairphone model? And is it
I am.
a realistic concept that could be scaled up or made mandatory for other manufacturing?
Right. Okay. Yes, I'm very familiar with the Fairphone. I don't know if you can, but this, you see, this is not a Fairphone. But if I was giving this talk 6 months ago, I would have had my Fairphone, and I just took it off the slide. This is twice I've taken it off the slide to simplify my slide, and immediately somebody asks me about it. So I better put it back on the slide. I've learned my lesson now. So Fairphone, then, for people who haven't heard of them, go and put them in your search engine, have a look for them. They're a little company in Holland, and they started from this conflict minerals, this tantalum conflict minerals agenda. They said, right, we're going to make a phone with conflict-free tantalum. And then they got really into it and said, we're going to make a phone that you're not going to give away after 2 years and leave in your drawer. You can keep it and upgrade it. And a very interesting business model. It nearly worked. I did get fed up with mine in the end and went and bought a second-hand phone. So, but really, I think that the importance of Fairphone is not that they're going to dominate the world of supply of mobile phones in the future, but they really set the agenda, which people like Apple and Samsung and everybody will now follow. If you go to their websites, you'll see they do indeed talk about responsible sourcing. So a really important flagship for responsible sourcing of digital tech goods. Yeah, very nice company.
Great. So I think that brings us to the end of our evening, but thank you so much. I think it just goes to show how important geology is to getting us a green future, a low carbon future, and sometimes is maybe overlooked a bit. But yeah, it's so wonderful to see how many ways we can make a difference as a geologist.
Yeah, I think watch this space, because I think, and watch the space when you go to buy things in the future and see if this agenda does come, because we see it coming through government circles and things at the moment, and through the way that manufacturers are talking. And I think it'll be very interesting to keep our eyes open and see how it comes into the labels on consumer goods that we're buying in the near future. Yes.
Thank you so much, and thank you to everyone who joined us, and please have